We're going to go over all the exponent rules that you should have already seen before. So this should be review. However, we'll pick up and see if there's some that you missed or some that you have forgotten. We always need to take care of our vocabulary first. If you don't understand the vocabulary, you can't do the work that we have to do in Algebra 2. So I want to ask you first, what is the exponent in this expression? The exponent is 4. What is the base in this expression? And the base is x. The definition of the base is anything that has an exponent. A base is anything that has an exponent. And what is the 3 in this one? Because that's pretty important as we discuss things. That's a coefficient. It's not stuck to the x. It's not a part of the x. It is a coefficient, which means it's multiplied by the x. So I understand, you need to understand what a coefficient really is. All right, so let's take 3x to the 4th and see what it actually means. This is a little like a text message. When you say, where are you? You don't spell out A-R-E or Y-O-U. You just, so this is like a text message telling you what is happening. And what's really happening is 3 is multiplied by x to the 4th. And x to the 4th really means there are 4 x's. So this is what is really being said when you have 3x to the 4th. Well, how does this work then? Let's look at this one right here. If we spread this out in expanded form, this says 3 times x to the 5th, and it's 2 times x to the 4th. How will this help us? Well, we'll use the commutative property of multiplication, which means when you're multiplying, you can kind of switch things around, can't you? So let's put the 3 and the 2 together. So now we have 3 times 2 is 6, and we have all of these x's, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we have 6 x to the 9th. So do you remember all the rules that allow you to do this? We want to cover one last thing for base, though, and vocabulary. If I just had an x just sitting there, what is the base? Well, that is the base. Now, we discussed how a base has an exponent, so what is the exponent? The exponent is 1. Everything has an exponent, and if you can't see it, what is it? It's a 1. Does this have a coefficient? It does. It's a 1. Remember how we don't write them, but we are supposed to know that they are there. So there's 3 things here I need you to understand. If an x is just sitting there, it can be a base, and that base has an exponent of 1. Now that right there is going to help you so much if you will always remember it has an exponent. So even if I don't see it, it still has an exponent and a coefficient. All right, so let's start talking rules, and you might want to get out your little note page and make sure you follow along and write some examples as you go. A to the 0 equals 1. What that means is anything to the power of 0 still equals 1. 8 to the 0 equals 1. X to the 0 equals 1. 4,922 to the power of 0 equals 1. Anything to the power of 0 equals 1. And this is very important as we go forward. All right, identity rule. A to the 1 equals A. This is what I was talking about. Anything that you see has an exponent. If you don't see it, it's a 1, and it's reminding you that 6 to the first power is still 6, and x to the first power is still x. That's the identity rule. So if we have 2x squared y, what are the exponents of the 2 and the y? Because we said everything has an exponent, doesn't it? Well, the exponent of the 2 is 1 because everything has an exponent. And y has an exponent of 1. Everything has an exponent. Please grab hold of that and hang on. Everything has an exponent. All right, the product rule. A to the m times a to the n. You add the exponents. Now, I think sometimes when we get right here, we are forgetting that we are multiplying. We are multiplying the same base. And the shortcut to multiplying the same base is to add the exponents. So let's try this. 6 to the 4th, 6 to the 2nd, and 6. We are multiplying the same base. And the shortcut to multiplying the same base is to add the exponents. So if we add up the exponents, we get 7. Well, maybe you can't see it that well, so let's try this. We have 4 6s, we have 2 6s, and we have another 6. So how many 6s do we have? We have 7. What we're trying to say is we're not changing the base. We're not multiplying the 6s by each other. We are writing our text message to tell you how many 6s there are. Now, some of you might have forgotten that there was a 1, so 4 plus 2 plus 1 is 7, so that's 6 to the 7th. Let's say this again. The shortcut for multiplying the same base is to add the exponents. The shortcut for multiplying the same base is to add the exponents. So let's try a few. What do you think? Did you see 10? Well, let's expand it for them because some of you might have forgotten that there was a 1 right there. So if we do it in expanded form, there are 5 x's, there are 4 x's, and there is another x. So there were 10 x's. What about the next one? Do you have an idea what the answer is? Did you get 12? Did you try to get something like 25 or 100? No, we're just finding out how many 5s there are. There were 6 5s, there were 2 5s, and there were 4 5s. Therefore, there were 12 5s. We didn't multiply anything. We're just deciding how many 5s there are. All right, what's the last one? Anybody got an idea? Did you remember to put a 1 on the S? All right. The quotient rule, 6 over 4, 6 to the 4th over 6 squared. Our rule is that we subtract m minus n, m minus n. So 4 minus 2 is 2. Here's what I find though. When we get to this point, you have no idea why you did that. You have no idea why you subtracted. So let's look at what's really happening. Let's use expanded form to decide what is happening. Well, we have 1, 2, 3, 4 6s on top. We have 2 6s on bottom. Does anything come to mind? I think I can cancel 2 of the 6s because there's a 6 on top, 6 on bottom. That makes 1. 6 on top, 6 on bottom. That makes 1. So what we have is 2 left. That's why you're subtracting, is you're thinking about how there's 4 on top, there's 2 on bottom, and you needed to cancel. All right. So let's try another one. Well, I don't want to do expanded form on this, so I'm just going to subtract. If I have 24 on top and 22 on bottom, then I have 2 left. So now let's look at this. X to the 3rd over x to the 5th. Let's use our little rule. 3 minus 5. 3 minus 5 is x to the negative 2. 3 minus 5 is negative 2. But x to the negative 2 really means 1 over x squared. What? Well, let's reason this out. Let's use our expanded form again. I have 3 x's on the top. I have 5 x's on the bottom. Probably it occurred to you that we could start canceling. Well, look at that. There's only 2 left, but where are they? They are on the bottom. Okay, so we have something new going on, and that's a negative exponent and what it means. So let's talk about this. Negative exponents mean I'm in the wrong place. You need to put me in the right one. If I have x to the negative 2, what it really means is 1 over x squared, that the negative 2 was in the wrong place, and now I've put him in the right place. Well, what if I end up with this, 1 over x to the negative 4? Well, a negative exponent means I'm in the wrong place, so I should push it to the top. Oh, this is hard. Okay, let's try this. I have this big mess right here, and I need to simplify it. The easiest way to start is write everybody that is in the correct place. Well, look at this. Y to the 4th, he's in the correct place. He's not negative, so he's in the right place. This x to the 4 right here, he's in the right place, so we're going to leave him. And z to the 5th is in the right place, so we're going to leave that one. Now let's look at x to the negative 3rd. Well, what does a negative exponent mean? I'm in the wrong place. Put me in the right one. So I'm going to put him on the bottom. I'm going to put him in the denominator. What about this one, x to the negative 2? He's in the wrong place. So I need to put him on in the denominator. And I got one more negative. I got y to the negative 3rd. Well, he's in the wrong place, but he's going to go up because he's down, and now he's going to go up to the numerator. Well, now that everybody's in the right place, it's much easier to see what I can do with this. Well, if I have y to the 4th and y to the 3rd, if I'm multiplying the same base, I can add the exponents. If I'm multiplying the same base, I can add the exponents. If I'm multiplying the same base, I can add the exponents. So, y to the 4th, y to the 3rd, that's y to the 7th. X to the 4th, x to the 3rd, x to the 7th, z to the 5th, z squared, z to the 7th. All right. Now, instead of adding the exponents, we're going to multiply them in y. Well, this time, we're not multiplying x to the 5th times x to the 3rd. What we're doing is taking x to the 5th and raising it to the power of 3. Again, instead of just memorizing, let's understand what they're saying. They're saying there are 3 x to the 5ths. There are 3 x to the 5ths. So let's write them. X to the 5th, x to the 5th, x to the 5th. And that really means x to the 5th, x to the 5th. Oh, there are 15 x's when I get done. So the shortcut to raising something to a power is to multiply. So the shortcut to raising to a power is to multiply. So what do you think this would be? This is 4 to the 20th. Very good. So let's put it all together. Now, does everything have an exponent? Everything has an exponent. What do I need to write? Okay, good. There is an exponent on the 3. The power rule means this is the power right here. I need to multiply. So I need to multiply 2 times 1, I need to multiply 2 times 3. I need to multiply 2 times 4. So I have 3, 1 times 2. I have x, 3 times 2, and I have y, 4 times 2. So what I really have is 3 squared, x to the 6th, y to the 8th. All right, it's getting harder and harder, isn't it? All right, the first step is to take care of the bottom. We have a power rule down here that we need to take care of. Do you see that 2 has to multiply by 4 and 2 has to multiply by 2? So on the bottom we now have x to the 8th and y to the 4th. All right, now we need to simplify because there's an x squared on top and an x to the 8th on bottom. Instead of subtracting, which I know you can do, I just want you to think for a minute. If I have 2 on the top and I have 8 on the bottom, and I think in my head, cancel, 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 what would I cancel? I would realize I would have x to the 6th on the bottom, wouldn't I? If I have 2 on top and 8 on the bottom, I would have 6 on the bottom. If I have y to the 8th on top, y to the 4th, then I would have 4 left on the top. And of course the z didn't have any problems, so we didn't have to worry about that. All right, try a few. I know this is difficult. We'll do one last little tool. I know this is a lot, but let's do one last little tool. I can break these up. If I have a division and I have it to the power of 4, I can actually break these into 2 pieces. And now it's easier to see that I'm going to do 4 times 2, which is x to the 8th, and I'm going to do 4 times 3, y to the 12th. This one was pretty easy and you probably didn't need to see it, but most times you will really help yourself by using this. Okay, go back to your little handouts, and I end with the most famous Star Wars saying of all. Obi-Wan waves his hand and says, "These are not the droids you are looking for."